Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 7, Understanding Equations. Opening exercise says your brother is going away to college, so you no longer have to share a bedroom. Unnecessary information. You decide to relocate a wall by hanging 2 new posters on the wall. The wall is 14 feet wide. Each poster is 4 feet wide. Okay? 2 posters. You want to place the posters on the wall so that the distance from the edge of each poster to the nearest edge of the wall is the same as the distance between the posters, as shown in the diagram below. So the distance from the edge of the wall to the side of the poster is equal to the distance between the 2 posters is equal to this edge of this poster and this edge of this wall. The total distance is 14 feet. We know the posters are 4 feet each, so what you would probably do originally is say, okay, well, 14 minus 4, one poster, minus 4, the other poster, equals 6. And if I have 3 areas that have to be the same, and they total 6, and 6 divided by 3 equals 2. So this would be 2 feet, and this would be 2 feet, and this would be 2 feet. Okay? So if we do this again, now we have 25 inches, feet. So the first thing I'm going to notice is we don't have the same unit of measurement. So this here, it's the same type of problem. This time we're placing 2 rectangular wall sconce lights that are 25 inches wide along a 10 2/3 foot wall. Stop right there, convert to inches, deal with the whole portion first, okay? And so on. So, there's a couple ways we can do this. This is 25 inches, so I can say 25 plus 25, but, okay, let me think about the second. There's a few ways you can do this, that's why I'm hesitant. First of all, we can say 25 inches equals 25 twelfths of a foot. Okay, because there's 12 inches per foot. Okay, and when I do that, 12 will go into 25 2 times. 12 times 2 is 24, with the remainder of 1. So 25 inches is 2 1/12 feet. Okay, then I can take. Now I've converted 25 inches to feet, so you can go that direction, or you can go from feet to inches. So let's just do this first. So now I have 10 2/3 feet equals, not equals, minus, so we're taking the total, minus the 2 1/12 feet for one poster, minus 2 1/12 feet for the second poster. Okay. And then once I do that, I find the total area or distance left over, and so then I need to divide by 3. So this is going to be the total. Minus one poster minus the other poster, it equals the space remaining. And if I want all 3 areas to be the same, then I'm going to divide by 3. So in order to finish this, I need to change my denominators to common denominators, and we're talking about, oops, that's not 2 1/2, it's 2 1/12. Okay, we're talking about feet and our common denominator, so we can add and subtract whole numbers, no problem. So I'm going to leave those for now. So it's going to be 10, but I don't want a 3 here because we have 12 and 12, so we have to have common denominators. So I want a 12 here. In order to make 3 12, we have to multiply by 4. 4 times 2 is 8. So it's 10 8/12 feet minus 2 1/12 feet minus 2 1/12 feet divided by 3. 10 minus 2 is 8. 8 minus 2 is 6. 8 minus 1 is 7. 7 minus 1 is 6, so I'm left with 6/12 feet divided by. Okay, now I'm going to reduce this to 6 1/2 feet. Right, 6/12 is a half divided by 3. Convert this from mixed to improper. 2 times 6 is 12, plus 1 is 13 over 2, divided by 3 over 1, and that is the same as taking 13 over 2 times the reciprocal of 3 over 1, which is 1/3, and I get 13 times 1, or 2 times 3. 6 will go into 13 2 times with the remainder of 1. That's this area here, and that area. Okay? You could also have converted to inches as well. I'm not going to take the time in this video to do that. Okay, so now the next thing says, let the distance between a light and the nearest edge of the wall be x feet. Write the expression in terms of x for the total length of the wall. Use the expression and the length of the wall given in the problem for an equation that can be used to find the distance. So we're talking about this last problem, and we're going to do it again, this one here. And our total is 10 2/3 feet. We have 3 spaces that we don't know, and we have 2 1/12 feet posters. Okay, so we're using the same problem. So I'm going to let the distance between the sconce, the light, and the nearest edge of the wall be x feet. So there were 3 areas that were called x. Let me go back and show you that. So what we're saying is, calling this x, the distance from the sconce to the wall, the distance from the sconce to the wall, and the distance between the 2 sconces is x. So there's 3 of them. So we're going to represent that as 3x. Okay, we're going to subtract the posters. The sconce width, which was 25 inches, or 2 1/12 feet. Okay, so it's going to be 3x plus 2 1/12 plus 2. Okay, so what am I doing here? The distance between the lights and the nearest edge of the wall is x. Write an expression in terms of x for the total length of the wall. So this plus the sconce equals the total length of the wall. Okay. Now we're going to make an equation of that. So then it says, then use the expression, this is an expression, no equal sign, and the length of the wall given to create an equation. So all they're saying is, take your expression and make it an equation. And when we go back, we see that the wall was 10 2/3 feet, so that's going to equal 10 2/3. Okay? Now to write an equation where y stands for the number of inches. Okay? For your total length of the wall. Then use the expression of the length of the wall to write an equation that can be used to find the distance in inches. So now we're going to do the same problem, but in inches this time. We're going to use y. So if we go back, we look, this 2 1/12 feet is 25 inches, and we'd have to convert 10 2/3 feet. Okay? So 2 1/12 feet equals 12 times 2 is 24, plus 1 is 25 inches. Okay? So now the expression is 3 areas that we're going to call y, plus 25, plus 25. Same as this, we just converted these into inches and changed x to y. That's what they asked us to do. Then it says, write an expression, done. Then use the expression and the length of the wall to write an equation. So now I've got to figure out what 10 and 2/3 feet equals in inches. Okay, and that is going to be 12 times 10, 120, plus 2/3 of a foot. If I change this to 12, multiplied by 4, that's 8/12, or 8 inches per foot. So it's plus 8. So it's 120 plus 8 equals 128. So I want to take my expression in terms of inches, instead of equals the total inches. Okay? Finally, it says, what values of y make the second equation true? 24, 25, 26. So this is substitution. So we want values of y, and here's my y. So I'm going to write 3 times 24 plus 25 plus 25 equals, and 3 times 4 is 12, 3 times 2 is 6, plus 1 is 7, plus 25 plus 25 equals, 25 plus 25 is 50, 72 is 122, so that is false. So it's not 24. Okay, now we're going to do it again. 3 times my y now is 25, plus 25 plus 25, let's see what that equals. Okay, and what we're trying to determine is if it equals this 128, so I should be writing 128 here. Okay, so let me rewrite this, and so I'm showing my work properly. So this is the way you should be doing it as well. So 72 plus 25 plus 25 equals 128. 72 plus 50 equals 128. And then finally 122 equals 128. And it obviously does not, so that is false. And that's the way I should be showing my work. My apologies for that. So this also has to equal 128 if it's true. 3 times 25 is 75, plus 25 plus 25 equals 128. Okay, and then 75 plus 25 plus 25 adds up to 125. That does not equal 128, so that 2 is false. Okay, now whenever you're doing a problem like this, do not ever stop after 2 and say the answer is 26. It may be all of them are false, so let's check. 3 times 26 plus 25 plus 25 equals 128. 6 times 3 is 18, 3 times 2 is 6, plus 1 is 7, plus 25 plus 25 equals 128. 5 plus 5 is 10, plus 8 is 18, carry a 1, 2 plus 1 is 3, plus 2 is 5, 5 plus 7 is 12, and this time it is true. So, the value that makes y, the second equation, true is 26. Okay? Okay, next example. The ages of 3 sisters are consecutive integers. The sum of their ages is 45. Calculate their ages. Use a tape diagram to find their age. Okay, keyword here is consecutive. If you have a consecutive numbers, and let's just say the basketball team won their first 3 consecutive games. That means they won game 1, they won game 2, they won game 3, but let's say they lost game 4, so that streak ended. Consecutive means in a row. If they then lost and then won game 5, then there's still only 3 consecutive wins. So that's what the word consecutive means, in a row. An integer is any number negative infinity to infinity, no fractions or decimals. So negative 3, negative 2, negative 1, 0, 1, 2, 3, going to infinity both directions. Okay? So, we want consecutive integers. Obviously, you can't be a negative age, and we're probably not dealing with a newborn. So let's start with 1s, 2s, and 3s. So it says the age of 3 sisters. So the answer could be 1, 2, 3. It could be 2, 3, 4. It could be 3, 4, 5. You get the idea? 3 numbers next to each other on the number line. 3 consecutive. Use a tape diagram. So if I say the youngest is represented by a tape measure or a tape diagram, we call that X. Okay? Then the middle child, well, if they're consecutive ages, the middle child has the same age as the first child plus 1 year. So this would be X, and that would be an additional year. The middle child's 1 year older. And the oldest would be the same age as the first child. Plus 1 year would be the same age as the middle child, but the oldest is 1 year older, so this child she is 2 years older. Oops, I don't want a 2 there. I want a 1 here, and then I want another square that represents 1 there. So that's a 1, and that is X. Okay? So all 3 of these add up to 45. If that makes sense. So there's a certain year, and then that year plus 1, and then that year plus 2. So I take 45 minus 3. These 3 years right here equals 42. Okay? So now I have 42 divided by some number equals 14. I'm sorry, 42 divided by the number of x's we have, which is 3, equals 14. Okay? So we take 45 minus 3, it's these 3, I should color code this to avoid because they're both 3's. Okay, this is 1, this is 1, this is 1, that is this 3. This is x, this is x, this is an x. So that is those 3 x's. Okay? You might confuse the 2 3's. Where are the 3's coming from? This is the individual ones. This is the number of variables we have. So 42 divided by 3 x's, and x would have to be 14. Okay? Now that we know this, we know the youngest child is 14. So we know that this one is 14. This x is 14. And this x is 14. 14 plus 1 is 15. 14 plus 2 is 16. So 14 plus 15 plus 16 consecutive equals 45. Okay? B. If the youngest sister is X years old, an unknown value, excuse me, describe the ages of the other two sisters in terms of X. Write an expression. So we just are basically explaining this up here as an algebraic expression. Okay? So the youngest sister, the youngest, is X years old. Y-O-U-N-G-E-S-T equals X. Okay? The middle child, or second, is that amount of years plus 1. Okay? And then the oldest is the youngest plus 2 years. Okay, so we're just saying x plus 2. X plus 1, x plus 2. And there are our 3 consecutive integers. So the sum of their ages would be x plus 1 plus x plus 2. Okay, there is the written expression. So there I just wrote the expression in terms of x. Okay, but we're not done. Now it says use the expression to write an equation that can be used to find their ages. So now I'm going to take this same expression, x plus 1, and we just put parentheses around these to indicate the child, keeping them separate from everything else. And now we know that their ages equal 45 years. So now I'm going to combine like terms. X plus x is 3x. Does it say to solve? Not yet. I'm getting ahead of myself. So there's the answer to the equation. X plus 1 plus x plus 2. Now it says, oh, same page, scroll. Determine if your answer from part A is a solution to the equation you wrote in part B. So we got 14 for my answer, 15 and 16. So we want to prove that with my expression. Convert it to an equation by setting it equal to 40. So what they're saying is solve this equation for x and see if it is that in fact true. So we now know that x equals 14. Okay, so we've got an answer for 14. So now let's just check to see if that's true. So we're going to substitute in 14 for this x, 14 for this x, and 14 for this x. Okay, so now when I do that, I add them up. This is 14 plus 15 plus 16 equals 45. 6 plus 5 is 11, plus 4 is 15. Carry the 1. 1 plus 1 is 2, plus 1 is 3, plus 1 is 4. And sure enough, 45 equals 45. That is a true statement. So my answer, if it asked how old are the kids, 14, 15, 16 years old. Exercise here is, how many do we have here? A, B, C, D. 4. Here are 4 exercise problems that you should try on your own. Pause the video and come back when you're done. Okay, Sophia pays $19.99 membership fee for an online music store. If she also buys 2 songs from a new album at a price of 99 cents each, what's the total cost? So this is just simply saying $19.99 for her membership plus 2 songs, 99 cents. Okay, add those up. 9 plus 9 plus 9 is 27. 9 plus 9 plus 9 is 27, plus 2 is 29. 9 plus 2 is 11, and 1 plus 1 is 2. So the answer is $21.97 for a membership and 2 songs. Okay, that's super expensive. That's all she ever buys because she just paid over almost $11 per song. Okay. All right. B, if Sophia purchases N songs for 99 cents each, write an expression for the total cost. Well, 99 cents per song, N, would be 0.99 times however many songs she's purchasing. So if N was 1, it'd be 99 cents. If N was 2, it's $1.98. If N was 3, it'd be $2.97, and so on and so on. Okay? Plus the membership. So there is our expression for the total cost of N songs. We don't know N. N is however many. It could be 100 songs. Okay. Now part C says, Sophia's friend has saved $118, but is not sure how many songs she can afford if she buys a membership in some songs. Use the expression in part B to write an equation that can be used to determine how many songs Sophia's friend can buy. So Sophia's friend really likes music, and she wants to spend every penny possible of this $118. How many songs can she buy for her iPod? So we're going to take 0.99n plus 19.99, and that equals how much money she needs, which is 118. Okay, there's our equation. D says use that equation in C, and can Sophia's friend buy 100 on 1, 100, or 99 cents? So I'm going to substitute 101 first. And see if it's true. Okay, 0.99 times 101 equals 99.99 plus 19.90 equals 118. Okay, this is for n equals 101. Okay, right here. So now 9 plus 9 is 18. 9 plus 9 is 18, plus 1 is 19, carry the 1. 9 plus 9 is 18, plus 1 is 19, carry the 1. 9, 10, 11. 119.98 is greater than 118, so she cannot buy 101 songs. That's too many. She went. Now we're going to let n equal 100 and write 0.99n, which is 100, plus 19, and see if it equals 118. So 99 cents times 100 is $99, plus 19.99 equals 118. Okay, I have a 9 plus 0, 9 plus 0, 9 plus 9, carry the 1, 2 plus 9, and that does not equal 118. She's over by 99 cents. So that's false. Well, this should chime in something for you right here. Some of your bell should be going off saying, oh, she's over by 99 cents, and that's how much a song costs, so one less should do the trick. So we're going to check that. N equals 99. 0.99n, okay, plus membership should equal 118. 99 times 99 is 98.01 plus 19.99 should equal 118. 9 plus 1 is 0. Carry the 1. 9 plus 1 is 10 plus 0 is 0. 10, carry the 1. 9 plus 1 is 10 plus 8 is 18. Carry the 1. 2 plus 9 is 11. 118 equals 118. That is true. She can buy 99 songs. So if there were 10 songs per album, she could buy 11. Let's see, if there are 11 songs per album, she could buy 9 albums. Or CDs or whatever. Okay. Below is the relevant vocabulary. Variable, equation, number, sentence, solution. You can review that on your own. That's the end of lesson 7. Problem set.